Hey, welcome back to Geometry. We're in Chapter 10, Section 4. We're talking about inscribed angles and polygons. Alright, so in your notes, start with a circle like this. Try to be as exact as you can. Make a good circle. And then we're going to make a little 90-degree central angle here. So, like so. Okay, move this over a couple. There we go. Looks good. Perfect. Okay, so this is a central angle. All right? Remember, this right here we call the central angle. Now, that central angle has an arc right here. That arc is 90 degrees, right? It matches the central angle. Now, if I put a point, let's name these. This is point A, point B, and point C. So A, B, C. Now, if I put a point over here on the circle, let's put it right there. That's a good place. You know what? Let's make this more harmonious. Happy for you OCD people. Let's go down right there. Okay. From here, if I make an angle from this point this way, okay, this, we call this point D, this is called an inscribed angle. Okay, an inscribed angle, if it's inscribed, it has its vertex on the circle. All right, and the sides contain chords. Okay, so the vertex is on the circle, and the sides contain chords. Okay, so the sides are raised, they keep going, but the first part of it is this chord right here. Alright, so that's an inscribed angle. Now, the really cool thing about an inscribed angle, it's hard to tell from this position. Okay, so I'm going to make another point over here because it's much easier to tell from this position. Okay, if I make an inscribed angle from this point right here. So it'll go through B, okay, and call that A, B, C, D, E. Okay, so EB, EA, alright? This angle right here. Try to look at that and see whether you can figure out what the measure of that angle is. Okay, if you can tell, notice it's going up 1 over 1, up 1 over 1, up 1 over 1. What do we call that angle? That is a 45-degree angle. Now, this one was 90 degrees. That one's 45. Okay, I can draw another angle down here. Let's move that away. Zoop, zoop. Yeah, somewhere down here. D is inscribed. There we go. Okay, draw another angle right here. So I call this point F. And then we're going to go through B this way. Notice that's also a 45-degree angle. So it's going through the same points. It's the same measure. If you went over and tried to measure this one, you would find this one is also 45. Okay, so first off, you can see if it goes through the same points, it has the same measure, and also this is the central angle. The inscribed angle that goes through the same points is half of the central angle. Since we don't always have the central angle here, we'll just reference the inscribed arc. Oh, sorry, not the intercepted arc. Okay, that's where this ray and this ray intercepts the circle. Those intercepts create an arc. It's called the intercepted arc. Intercepted arc. Right there. Now we know that arc is 90 degrees, and this measures 45. So the inscribed angle is 1/2 the measure of its intercepted arc. And then the other thing we talked about is that these measures are the same. So if two inscribed angles intercept the same arc, they are congruent. So this right here is the theorem 1010, half the measure of its intercepted arc, and this one, that all the angles, if they intercept the same arc, are the same, is theorem 1011. All right, let's look at a couple examples. Find the indicated measure. Super easy peasy. All right, because the measure t, that's this one, that's half of 48, so that's 24. Okay, and this one's 2 times 50, so that's 100. Boom, that easy. All right, find measure rs, this one right here. Okay, we know this is 31, so that's 2 times 31, so that's 62 degrees. And then str, str, all the way around, this way. So that's 180 minus 62, and that is 118. What do you notice about str and rus? Rus, they are equal. Are equal. And so there you go. Shoop. Given the measure of E is 75, find the measure of angle F. Notice that these intercept the same arc, and so this measure has to be the same as that one, making that 75 degrees. Easy peasy. Okay, an inscribed polygon is a polygon which has all its vertices on a circle. Okay, and the circle around the outside is called a circumscribed circle. Now, cool thing here with a triangle, if you have the diameter, then that means that this arc right here is 180 degrees, right? Because the diameter, that'd be 180 degrees. So think about it. What does that make this measure down here? Well, we have an inscribed angle of 180 degrees. That makes this, you are right, 90 degrees. So if you have a triangle whose with one side as the diameter, it means it is a right triangle. The other way around, if you have a right triangle, then the hypotenuse has to be the diameter. So that is theorem 1012, that if one side is the diameter, it's a right triangle. If it's a right triangle, the hypotenuse must be the diameter. And an inscribed quadrilateral, if you think of it, if we have the diameter here, and then these would both be 90, then the other two also have to add to 180, right? And so that's the case. Doesn't matter where we move them, because if I move this angle from here to here, but we still have those, then remember that doesn't change the angle of G, because I'm still intercepting the same arc. So what that leaves us with is that opposite angles are supplementary. All right, find the value of each variable. Well, here we have the diameter, which makes this a right triangle. Therefore, 2x is 90. And divide by 2, x must be 45. Boom. And then here, we know that opposite angles are supplementary. So z plus 80 is 180, or 180 minus 80 is 100. And then 120 for this side leaves us with 180 minus 120 gives us y. That is 60 degrees. Okay, quick word problem here. Your camera has a 90-degree field of vision, and you want to photograph the front of the statue. You stand at a location in which the front of the statue appears in your camera's field of vision. Right here, you're looking this way. You want to change your location. You want to move, but you want to still see both ends. Where can you stand so the front of the statue still appears in your camera's field of vision? Okay, so we know right here, that's 90 degrees. This would be the diameter of a circle. That's a terrible circle right there. I'll make a better one. There, that's better. So now, remember, you can stand anywhere on this circle and you would still have a 90 degree right here. You could stand over here, boom, and that would still be 90 degrees. So anywhere on that semicircle. There you have it. Lots of fun, good times. Check in again next time for another fun lesson.